An application load balancer is great for routing HTTP and HTTPS traffic, making it ideal for web applications. It can inspect the content of the requests and make intelligent routing decisions based on that. On the other hand, a network load balancer is designed for handling millions of requests per second while maintaining ultra-low latency. It operates at the transport layer and is perfect for applications that require fast, reliable connections. Lastly, a gateway load balancer combines the benefits of both ALB and NLB, allowing you to deploy and manage virtual appliances seamlessly. Think of it like choosing the right vehicle for a journey. If you need speed and agility, you might choose a sports car, NLB. But if you need to carry passengers and luggage comfortably, a minivan, ALB, would be better. In summary, selecting the right load balancer depends on your specific needs for traffic management and application performance. One tricky aspect that candidates often face in exams is the confusion between features and use cases. It's essential to clearly understand these concepts to visualize the deployment architecture effectively. The application load balancer operates at layer 7 of the OSI model. This means it works with HTTP and HTTPS traffic, allowing it to intelligently route requests based on specific criteria. For instance, it supports URL path and host-based routing. This means you can direct traffic to different backend services depending on the URL path or the host name in the request. Think of it like a traffic cop at a busy intersection, directing cars to different roads based on their destination. This helps ensure that users reach the right service quickly and efficiently. In summary, understanding the role of the application load balancer and how it routes traffic is crucial for effective deployment architecture. Imagine you have an application load balancer, or ALB, sitting in front of multiple targets, like EC2 instances or ECS services. The role of the ALB is to decide which request goes to which target. This is crucial for distributing traffic efficiently and ensuring that no single target gets overwhelmed. Now, on the other hand, we have the Network Load Balancer, or NLB. This operates at layer 4 of the OSI model and is designed to handle TCP and UDP traffic. It's optimized for high throughput and ultra-low latency, making it ideal for applications that require fast response times. One of its key features is that it supports static IP addresses, which can be very useful for certain applications. Additionally, the NLB excels at managing sudden spikes in traffic, ensuring that your application remains responsive even during peak times. In summary, while the ALB focuses on routing requests to specific targets, the NLB is all about handling large volumes of traffic quickly and efficiently. To understand its role better, let's compare it with two other types of load balancers. The application load balancer, or ALB, focuses on application-level routing, while the network load balancer, or NLB, is all about network-level performance. The gateway load balancer, on the other hand, integrates seamlessly with these virtual appliances, allowing for efficient management and scaling. In our lab, we will create a virtual private cloud, or VPC, and deploy EC2 instances across two different subnets. This hands-on experience will help you see how these components work together in a real-world scenario. In summary, the gateway load balancer is essential for integrating and managing virtual appliances, providing a distinct function compared to ALB and NLB. First, we will create both an ALB and an NLB. The ALB will be responsible for handling HTTP requests and will use host-based routing to direct these requests to the correct target group. This means that depending on the host name in the request, the ALB can send traffic to different backend services. On the other hand, the NLB will manage TCP traffic, ensuring that it is routed efficiently to the appropriate destinations. Additionally, we have the option to integrate a gateway load balancer. This allows us to connect optional appliances, which can be useful for various purposes like security or monitoring. To put this into perspective, think of the ALB as a traffic officer directing cars at an intersection based on their destination, while the NLB acts like a fast highway, ensuring that vehicles can move quickly and smoothly to their endpoints. In summary, the ALB will route HTTP requests correctly, the NLB will handle TCP requests efficiently, and the gateway load balancer will facilitate traffic through integrated appliances. When preparing for exams or real-world applications, candidates often make some common mistakes. One of the biggest errors is confusing the features of application load balancers, ALB, and network load balancers, NLB. It's also crucial to understand the differences between Layer 4 and Layer 7 routing, as this can significantly impact how traffic is managed. Additionally, many overlook the use case for gateway load balancers, which can be vital in certain scenarios. To approach this safely, always choose the correct load balancer based on the type of traffic and latency requirements you have. Make sure to configure health checks properly and monitor your setup thoroughly. In summary, understanding these concepts and avoiding common pitfalls will help you effectively manage your load balancers and ensure optimal performance for your applications. The Application Load Balancer, or ALB, is designed for HTTP and HTTPS traffic. It works at the application level, which means it can make smart routing decisions based on the content of the requests. On the other hand, we have the Network Load Balancer, or NLB, which is optimized for TCP and UDP traffic. It is built for high performance and can handle millions of requests per second while maintaining ultra-low latencies. Lastly, the Gateway Load Balancer is used for integrating virtual appliances, which can be very useful for security or monitoring purposes. It's crucial to remember that selecting the right load balancer for your use case and architecture is critical. Think of it like choosing the right tool for a job. Using the wrong one can lead to inefficiencies. So to recap, each load balancer serves a specific purpose, and understanding these differences will help you make better architectural decisions.